find the integral double integral of x minus 3y squared dA, and what is your region? And your region R is defined as the set of all points x and y in xy plane. You have like this rectangular shape, such that x is in between 0 and 2, and your y is in between, what we have, 1 and 2. 1 and 2. There you go. So you look at your function. Hey, I have a nice function. This function is continuous everywhere. So you say that since we have a continuous function, then the double integral of x minus 3y squared dA can be calculated two ways. Let me show you both of them. So the integral, let us have the inner integral with respect to x. So here you have x minus 3y squared dx dy. So your x ranges between 0 to 2. First you have to evaluate the inside integral, then your y ranges between 1 and 2. So I'm taking the integral with respect to x. Here I have the integral 1 to 2. The inner integral with respect to x, remember that the integral of x dx was x squared over 2 and constant of integration. So here you have x squared divided by 2 minus, so this is just a constant. So we're going to copy down 3y squared times x. Now you have this quantity, it ranges between 0 to 2, so x 0, x to 2, you have a definite integral. Then you take the integral of this quantity after calculation with respect to y. So this is equal to the integral 1 to 2. Let us plug in 2. We get 4 over 2 minus 6y squared minus, if I plug in 0 here and here, the outcome is 0. So I'm not really worried about the second one. Now I'm taking the integral with respect to y. So if you simplify this, you get the integral 1 to 2, 2 minus 6y squared dy. Okay, perfect. So I have 2y minus 6 over 3 y cubed, and my y ranges between 1 to 2. Let us plug in 2. You get 4 minus, if you divide these two, you get 2. 2 times 8, 16 minus, now if you plug in 1, you get 2 minus 2. This is just 0, so we're not really worried about that. So here you get 4 minus 16, which is negative 12. I expect you to ask, what if I take the integral with respect to y first? Do I get the exact same result? The double integral? Okay, let me show you. So, or you can say that, hey, this is the integral of the integral x minus 3y squared dy dx. So I'm going to take the integral with respect to y first. My lower limit is 1, my upper limit is 2. For x, it is 0 and 2 to this x. So now you can take the integral with respect to y, and then take the integral of that quantity with respect to x. There you go. Here you have the integral, 0 to 2. So you're taking the integral with respect to y. X times y minus 3 over 3 y cubed, and your y ranges between 1 to 2. Then you take the integral with respect to x. So you have to calculate this quantity first. This is equal to, if I plug in 2 here, I get 2x minus, if I plug in 2 here, it needs to cancel out, I get 8 minus. If I plug in 1 here for y, I get x minus 1. This is the integral 0 to 2 of this quantity with respect to x. Okay, I can simplify this. Of course, this is equal to the integral 0 to 2, 2x minus 8 minus x plus 1 dx, which is equal to, let me just simplify this here. I get x minus 7 dx. Very well. So the integral of x is a half x squared. The integral of negative 7 is minus 7x. My x ranges between 0 to 2. So if I plug in 2, I get 4 divided by 2 minus 2 times 7, 14. And if I plug in 0, both of these are 0, so I'm not really worried about that. So I have 2 minus 14, which is negative 12 again. The same exact result. Page 6. So before giving you the theorem, I just wanted to give you this example. It says find the double integral of this function sine x cosine y dA over region R, and region R is defined as just a rectangular shape. Here you have all xy such that x ranges between 0, pi over 2, and y ranges between 0 and pi over 2. Very well. What is this double integral? Okay, very well. You can say that, hey, I want to take the integral with respect to x, then with respect to y, or I want to take the integral with respect to y, with respect to x. Take a look at this. You have the integral, double integral, sine x, cosine y. Let's take the integral with respect to x, then we take the integral with respect to y, 0 to pi over 2, 0 to pi over 2. The lower limit and upper limits of both of them are the same. So what are we doing? We are taking the inner integral with respect to x. What's the integral of sine x? The integral of sine x is negative cosine. So here you have the integral 0 to pi over 2. This quantity inside, you get minus cosine x times cosine y, and your x ranges between 0 to pi over 2. Then you take the integral with respect to y. Okay, let's plug these values in. Here we have integral 0 pi over 2. So if you plug in pi over 2, the cosine is equal to 0. So you have 0 times cosine y minus, if you plug in 0 here, you get 1. And since you have a negative sign, you get negative 1 times cosine y and dy. So this is just 0, and this is the integral 0 pi over 2, and we have cosine y dy. What's the integral of cosine y? The integral of cosine y is nothing but sine y. Y ranges between 0 to pi over 2. So sine of pi over 2 is 1. 1 minus 0, which is 1. Now, what if I take this integral and write it as multiplication of two integrals. What do I mean by that? Here I have the integral of sine x cosine y dx dy. My x ranges between 0 to pi over 2. My y ranges between 0 to pi over 2. What if I write it this way? Am I allowed to write it this way? It's the product of the integral of sine x dx, x ranges between 0 to pi over 2, times the integral of cosine y dy, y ranges between 0 to pi over 2. Well, you're allowed to do that. Why is that? Because this function is a function in variable x. It doesn't have any connection with variable y. This is your f of x. And here you have cosine y. It's not connected. It doesn't depend on variable x, just variable y. So you can say that, hey, I have f of y. So I can separate these two integrals and actually use the methods that I learned in Calc 1A elementary calculus, find each of these integrals and multiply the results. Take a look at this. The integral of sine is negative cosine x, x ranges between 0 to pi over 2, times the integral of cosine y is sine y, and y ranges between 0 to pi over 2. So here you have negative 0 minus 1 times, here you have sine of pi over 2, which is 1 minus 0. Here you get 1 times 1, which is equal to . Our last example. Very well. Our last example says evaluate the following. Evaluate this integral. Double integral of y times sine xy dA over region R. We define region R to be a rectangular region, which is, okay, 1, 2, and y ranges between 0 to pi. Can you separate these two? Unfortunately not. This is a function, of course, it's just has a variable y, but this function depends on x and y. So we cannot separate these two integrals. Very well. So you might say that, hey, I want to start by taking the integral, inner integral y sine xy with respect to x, then with respect to y. So I'm going to calculate my inner integral. My x ranges between 1 to 2. My y ranges between 0 to pi. So let's calculate the inner integral first. Here we go. Okay. Here you have the integral of sine xy. The integral of sine xa dx. Remember how you take the integral when you have a value multiplied by your variable x, this is equal to negative 1 over a cosine x a plus constant of integration. Very well. So in this case, you're going to have the integral 0 to pi. Here, okay, so take a look at this. X times y, y is the constant, which is actually here. So we're lucky. This integral is nothing but negative cosine x, y, and x ranges between 1 to 2 dy. Very well. So let us do the calculation here. This is equal to the integral 0 to pi minus, so let us plug in 2 here, so cosine 2y minus, here we have cosine of y. Cosine of y. dy. So your integral is equal to 0 to pi, and let's just distribute that, cosine y minus cosine 2y dy. Now, it's an easy integral. We can just take the integral. This is equal to, so we have our cosine, we get sine y minus a half sine 2y, and y ranges between 0 to half. So let us plug in pi. Of course, this is 0. If you plug in 0, this is equal to 0. So no matter what value you plug in, the outcome is equal to 0.